Good morning, and thank you for letting me talk to you about the OLED technology. And as Patrick said, I'm talking about Ljus. Most people don't understand how to pronounce it. Ljus is actually Swedish for lighting. And in case you can't tell from my accent, I'm not Swedish. But the OLED is a great technology. So I'll give you a quick overview. This lighting technology is a spin out from the Wake Forest Center for Nanotechnology and Molecular Materials. It's really the first significant lighting in the last 20 years. The last was really OLEDs. We were founded in February of 2014, so we're a little over 2 years old. And we filed patents globally. So one of the things when you talk about lighting, most people don't quite realize, but 25 to 30% of all electricity used in the U.S. goes into lighting. If we could get to 150 lumens per watt, now a lot of people say the LEDs are 150, but the actual lights themselves are not 150. They're closer to about 100. If we could get to 150, we would save 273 terabytes of energy per year. That's phenomenal. So it has a big impact. So exactly what is the OLED? You may have heard of OLEDs. Most of you have heard of LEDs. LEDs are light-emitting diodes, and they're usually inorganic chips. OLEDs are organic light-emitting devices, and they're from organics, and they can be across the surface. OLED is organic light-emitting varactor. So it runs, OLEDs are direct injection. We are capacitive driven, so with that we can get a much higher efficiency and a lot better control. So there's 5 things that you need to know about the OLED that makes it different. It is an AC driven device. OLEDs, almost all OLEDs, a little bit's been done with AC, but their OLEDs are almost all DC driven. Our lighting coming in is AC, so if you can have a lighting that's AC will be a big help. The other thing is you can make them conformal, you can make them out of plastic, you can light the wall, you can do a lot more with OLEDs and OLEDs than you could with any other devices. OLEDs are much brighter than OLEDs, and that's because we can get them capacitive driven, and the other thing is they become more efficient the brighter they go. Usually most OLEDs are only about 3,000 candelas per meter squared. We can get up to 30,000 or even higher. The hours of operation are greater than 20,000. The other beauty about the OLED that's different from anything else is we can achieve a color spectrum that is the closest matching light to the sunlight that there is. We don't quite have the thing, but we do have a full spectrum. And if you're working in lighting, there's a lot of stuff, if you see our sign, that lighting has a big health impact, that the better the lighting you have, it has a big impact for growing fruits and vegetables. We also have a lot of our colleagues, our friends in Colorado have been asked to us to develop a lighting source for their markets. But the one thing it does do is we will be able to get better grow lights than any other light that's out there. And they're extremely efficient. We will probably get over 200 lumens per watt, and we've shown higher. I'm just a little cautious about going higher, but it has a great potential for being more efficient. And the cost is very cost effective because, as I'll show you with our filaments, our cost for an OLED will be roughly 20% of an OLED, so it makes it very cost efficient. So when you're doing a startup, one of the key things you need to do is technology is great, but really to get sales, you usually have to sell a product. So one of the things is we've come out with a minimum viable product. And if you look at this, we call it this like a pendant light. But the beauty about this and the fact that it is so bright, we actually only need a filament. And this filament will light the whole thing because we can output couple, something that you can't do in LEDs because LEDs create the light, but it's a pinpoint, a lighting source, and so you have to disperse it. So with our filaments will be very cost. They can be replaced. You can't really replace LEDs. So even if we're not with our first product is that great, which it will be, but you could also replace it. You could replace it to a different color, you could to a different brightness. And so that's our minimum viable product, and as you just heard from Michael, we actually make these from 3D printing. And so we can actually design these type of lightings to fit a customer's needs, and they can just replace the filament. So the other thing is when you compare it to LEDs or OLEDs, we're by far, you see in the green, that we are by far the best performing light. I'd like to thank you. If you have any questions or have a thing at the back, but it is exciting light, and it was invented here, and we hope to invent and manufacture in Winston-Salem.